Hi, this is Tom Cherryholmes with the FujiNet project. In the previous video, you saw me take and send stuff from the Atom to my development PC. Now we're going to take and send some data back to the Atom to display on the Atom here. As I mentioned before, in the previous video, I'm actually just kind of using additional cycles here to work on a little game of a little port of Targ here, a game that really would fit very well in with the ColecoVision's color palette and its features and capabilities here. So it's definitely something that can be used to exercise the OS 7 bindings that I'm putting together. But I digress. I mean, we can see all the individual pieces here. We can see color palette right here. This is a direct screenshot from the game. I went through and verified as part of the process here that all the objects and everything else were all 8 by 8 and easy enough to take and to convert into tiles that can be displayed on the ColecoVision. Everything's good there. So now the next thing is, well, how is this? Just kind of do a quick little run through of how this is going to look on the ColecoVision or the Atom itself. And to do that, just quick and dirty, since the screen size was vertically oriented originally here, I had to take and just cut off the bottom part of the screen here. You can see with the dotted line here, the bottom part of the screen here. So just, okay, fine, we'll cut that off and reformat the screen based on that. Cool. So given that, we wind up now using a little piece of software called Convert 9918 to take and convert that into a format that the ColecoVision slash Atom slash TMS 9918 can actually handle. So we'll go ahead and open it up. We'll open up the targ test ping that we did here, and it's rendering it out. And you'll see that, yeah, of course, there's some color clash there. That's to be expected, but you'll see that it's really kind of immaterial. All the main pieces map out nicely, and this will work out okay. Cool. Okay, well, let's save this in a raw format to start with here. We have bitmap mode 9918. We'll go ahead and save this in raw format, which just saves out the raw binary bits that would be sent to the video chip. There's one file for color data and one file for pixel data. And we'll go ahead and if we save it, yes, go ahead, because I've done this before through the magic of editing. Okay, go ahead and clear that. We wind up with two files here on the desktop called targ, along with our targ test file here. And these are exactly the size that we need to shove them into the various banks of the VDP here. Well, on the other side of this equation, I wrote a little program on the Atom, just called bitmap view. If we run it, we'll see that it's waiting. And what has actually happened here is it has actually opened up a listening connection. That is, it's listening for a network connection on port 6502 of the FujiNet's IP address. So it just so happens that the host name of this system is called Atom. And you can see I can ping it right there, talk to it just fine. But if I now take and use netcat like I did before in the opposite direction, I can now take the two files, the pixel data and the color data, throw them into netcat, and we can see the result on the Atom screen. Grabs the data, calculates, and then blitz it directly to the screen. So you see right there, this was a program I wrote in about 20 minutes. I took and put this together in about 20 minutes to show that it could be done. And once it's done, it finishes the connection, and closes it off. So if I want to take and send something else, I go ahead and send it again. It waits for the connection, gets another connection here, bounces it back out again. There, I can see the results. So I can see the results of things that I'm working on natively to see how they take and they map out on the real thing. And FujiNet makes that really easy to do. I'm going to go ahead and end the video here. So I just wanted to take and show you guys here and really try to drive these points home. So until next time, guys, have fun.